What about the next one? We call this the common emitter. Something like this, CV. Hey, and put your 1040, get it, buddy. CE for common emitter. How do we know? How do we know it's a common emitter? Hey, look at that thing. Inputs on the base with respect to the emitter. Outputs at the collector with respect to the emitter. And there's something cool about this one. Everything's what?
High.
Everything's high with a common emitter. But first things first, base, input, outputs at the collector. What about the phase relationship between the input and output? Yeah. This is a 180-degree phase shift. 180 degrees out of phase. Current gain.
High.
Current gain is high, or can we say very high? Yeah, we'll say very high, because that will indicate what our power gain is going to be, because it has to do with, but again, if you're looking for very and you don't see it, would you just pick high? If that's all you see? Yeah, it's just relative. So very high, current gain. Well, the output's here on my collector, and if you want to consider this, 5% on the base, 95% on the collector, current, because I always use percentage to represent current. Could I say that that's basically equal to transistor beta? Yeah, because look, base collector. So I can do something like this, parentheses, transistor beta. Do that. What about the voltage gain? We'll call it very high again. Output is at the collector, just like this one, but we're dealing with a little bit more current, a little bit more potential here, which our result in power gain will be what? Extremely high, because very times very is extremely. And I already told you everything's what in a common emitter? High. During the lessons, we went through the how and the why. Now it's kind of a Barneyized method of going through this chart again. So far, so good? Can you do it there, Mr. Walerius?
Yes, sir.
Okay. Input impedance. Well, it's on the base, the input that is. What did I tell you about input being on the base as far as impedance goes? It's always going to be high, very high. No, you're saying low. Base! Input's on the base, it's always going to be high. What do we normally have at the base? Voltage divider resistors, the base collector's reverse bias, there's a significant amount of opposition to the input. It's always going to be high, or very high. Got the word high in it, that's the damn answer. High. Where's the output? Collector. What's the output impedance look like? Huh? High, very high. What does your chart say when I originally gave it to you? Very high, high. Height also high. Because again, we're dealing with reverse bias, base collector. We've got collector resistor out there. From collector, we're going from collector to emitter. There's a significant amount of opposition there, and typically you're going to have an emitter resistor. So I was taking into consideration. Nickname for this guy.
Power amplifier.
Power amp. Oh, gee whiz, if everything's high, current times voltage, very times very extremely. Oh, extremely high power must be a power amp. This is the most common configuration you will see. Common emitter.